Hello, everyone, and welcome to the fifth session of the Snowflake Educational Series powered by BluePie. My name is Tanika, and I will be your host for today's session. In case you have missed out on the previous sessions, please check them out on our YouTube channel. You can find the link to the same in the chat box. Now, I'd like to introduce today's speaker, Divya Das. He is working as a tech lead in BluePie and handles data analytics projects. He will be talking about data lakes. He will tell us what data lakes are, their history, and how are they maintained in Snowflake. I hope you guys enjoy the session. Over to you now, Divya.
Hello everyone, I hope you are able to see and hear me. Let me just give me a moment to share my screen. Hmm. Just give me a moment. I'm not able to share my screen. That's weird. Let me try sharing my entire screen. Okay, let me try again. Let's hope it works this time. Uh, Mm, not showing screen of the other tab. Try it this way.
Hi everyone. So Divya is facing some system glitch. We'll resume the session in 5 minutes once that's figured out. Uh, Thank you for your patience.
Okay, third try. Uh, this is present review tab. Finally. So I hope you guys are able to see my screen now. So I'll proceed with the presentation. Uh, so finally, good afternoon, everyone, and thank you, Tanika, for the introduction. Um, this is the fifth session in the Snowflake Educational Series, and in today's session, we are going to talk about the data lake workload in specific, and primarily we are going to talk about what are data lakes, and then their history, and then how do you go and set up data lakes in Snowflake as well. So with that in place, let's get started. So the very first question is, what is a data lake? And this is for those who are completely new to the concept. So simply put, a data lake is a place where you can store all of your enterprise data in one place. Now you would ask, why do you need to do so? Because the main reason for that is, let's say in your enterprise, let's say you are working for a big enterprise, or you have a project for an enterprise which have 5 to 10 databases. Now if you want to do some cross database analysis, you would need to have that data in one place for you to be able to pull out meaningful insights out of that data. And one other point that I mentioned here is a place where you can store all of your enterprise data. So, what's the definition of all the data here? So, typically, a enterprise or even a medium scale business have multiple kinds of data. It can be structured data, which is coming from your OLTP databases, or it can be semi-structured data, which is coming from your website logs, website feed, the clickstream data. And then some companies, most of digital native companies, they do and work upon unstructured data as well. They process text files, images as well to run their day-to-day business. Now, with the boom of big data, most of the companies do want to analyze this all data that they have. And for that purpose, the need of data lake has uh, arisen in the last a decade or so. And one other important point that I would like to mention here, that data lake is not a technology, but rather it's a concept that is needed to be implemented for you. And the end goal, of course, is for you to be able to analyze all the data that is there for making data driven business decision within your organization. So we are done with what is data lake. Now this is not all there is to a data lake, but with the intro in place, let's first see now what are the various use cases which led to the uh, uh, sunrise of data lake. So when I say data lake, the term data lake got introduced 10 years back only, but prior to that as well, people used to do some analysis, and enterprise did have 5 to 10 databases, right? So how did they used to do it? So uh, the approach previously that was taken was data warehouse. And as you know, data warehouse is a term, and it is being implemented since the last 3 decades. So why do we even need a data lake when we already had a data warehouse in place? And if I have to repeat, I mean, a data warehouse is also a place where you segregate data from different sources and do your data analytics over it. Why a data lake then? So the answer to this question is because of the advent of big data technology, data warehouse was just not able to meet the needs of the data analytics. And it comes from the three views of big data as well: the volume in which the data is coming, the variety of data, and the velocity of data. So data warehouse, they were primarily structured to, so they are relational in nature, right? So there are, if you see facts and dimension, there in data marts are there in a in a typical data warehouse, but they are not meant to analyze your semi-structured or even unstructured data. So when the organization had such a huge amount of data, they saw that they could go and analyze this data. But to do that, they needed data in some segregated place, and that place they termed as data lake, where they just dump all their data in, and then once the data is there, then after that they will think about, now let's see how we can go and get some useful insights out of this data. Some of the popular data lake which are provided by cloud vendors right now are AWS S3, Azure Blob Storage, Google Cloud Storage, ADLS Gen 2, and I'm naming this at the last, but this is the one that came the first from all of these four, which is HDFS, which is Hadoop Distributed File Storage. So with the reasons in place, let's first now let's see. Excuse me. What's the history of data lake? So Uh, we'll start from the first. The very first data lakes that people used to implement within their organization were they will just take one separate on-prem database and then they will use it as a data lake. So what I mean to say by that, let's say they have five different OLTP databases, and now they want to do some cross database analysis. So what they used to do was they will provision one more database which was on prem, and then they would basically transfer all their data from these five databases to this one database which is larger in size, of course, and then they will do their analysis over this database. But then soon, as the data volume rose, since it was on prem, it was very difficult to scale. So this architecture didn't fly. Because with the advent of big data, the data used to come in the volume of petabytes, and as we all know, on-prem are not scalable. So this was an architecture which didn't fly. The second architecture that came in and which revolutionized the big data world was Hadoop ecosystem. And within Hadoop ecosystem, there's HDFS, which stands for Hadoop Distributed File Storage. So Hadoop ecosystem is it was a system which gave you the capability for distributed compute and storage. So basically, within on-prem, you would have, let's say, 10 computers, and your data would be segregated on those 10 computers, and your computation will happen also on those 10 computers only. So many organization, when Hadoop ecosystem came into picture, they implemented their data lake on the HDFS. But then there were issues with HDFS as well, and one of the main reason why HDFS is no more right now. I mean, uh, I don't know any customers or any organization which still uses or are not trying to move away from HDFS as their data lake solution, was the difficulty to implement the system altogether. What I mean by that is, it was an on-prem solution, and you needed very specialized kind of data engineers even to make the platform running 24 by 7. And then the platform was, since it was on prem, it was not easily scalable. Of course it was scalable, but let's say if you have to add one more node, for that you have to take some downtime, and then you'll add one node, and then you'll have one or two more nodes. But that is not something, once you are in production, that is going to fly. So that these were not all, but some of the limitations of HDFS. Then came in blob storage by the popular cloud providers right now. So these are AWS S3, Azure Blob Storage, or Google Cloud Storage. So what they offer is, first, it is in cloud, and it is completely scalable. And one more advantage that this type of data lake architecture has is distributed compute and storage. What I mean by that is, in HDFS, within your nodes, the same node had data as well, and the same node had compute as well. So if you had to do some analysis over less quantity of data, you would still need to cater to a very big architecture just to run some small query on some small amount of data, and you would need to pay for that as well. But that is not the case here, and that is how a data lake architecture should be as well. The compute and the storage should be scalable separately from each other. But one limitation which is there in these type of storage as well, if you go for a data lake implementation, is in them, is that they store your files in blob storage. What I mean by that is, if let's say you have a table of 1 GB, and then they will segregate this 1 GB file, let's say, into chunks of 128 MBs. But then these will not be tables in your relational database. These will be separate files of 128 MB each. And if you have to query this data First of all, you will have to marry it, not marry it together, but this is not apt for data analysis, because as you know, data analysis, if you are doing on a table, uh, the best storage that is suited is columnar storage, and that was not there. So after that, the current modern data lake architecture, which is supported by Snowflake, is you have your data lake and data warehouse on the same platform. So instead of files of instead of blob storage, even the data lake will be a will only be a table only in your architecture, which makes your data analyst capable to go and query the data directly to the rawest form of data. So as I said, data lake is used for you to be able to do your analysis on the data, and there are many architecture which could be suitable for your organization. So it's a choice that you have to make for your architecture. Now, what are some of the characteristics of a successful data lake architecture in the modern world? So first of all, it should be scalable, because with big data, uh, petabytes of data will come in, and your system, your data lake should be able to scale. It should be resilient. There should be no data loss. There should be multiple copies of data, and that is provided in the last two architecture that we just saw. There should be independent scaling of compute and storage. We already talked about it. There should be easy access to end user with governance and security. Now this point is very, very important. I cannot stress this enough. When you have petabytes of data in your data lake, and if you are not able to govern and secure it properly, the compliance, if you are working in an enterprise, the compliance just won't let your project fly. I mean, the person who signed the NDA, his neck will be on the line if uh, s- some amount of data is lost, or it get in the hand of someone which it's not supposed to be. So governance and security, this is very important aspect while you are making a data lake architecture for your organization. Uh, and this is one of the point which was missing in the in the blob data lake architecture. The main reason for that is you pull in the data into your blob architecture, and then if you have to analyze this data, you are not able to do your analysis directly on it. Maybe you will have to use one more service, let's say a Hive or a Presto, to run your query over it, and then you will have multiple copies of data. Maybe you will put on a separate data warehouse as well. Now there there are multiple systems where you have to go, and then you have to apply the same governance and same security over all these systems. Now when there are multiple hops of data within one system, and when the volume of data is also in petabytes, it is very difficult to apply a very good governance and security policy. So if you are going to make a data lake architecture, this is a must have. Another point is data cataloging and data quality in place. What are these two terms? By data cataloging, I mean, let's say not even petabytes. Let's say you have 100 GB of data. Now, and let's say you have 50 tables. Now, if you do not know what's where is each of these, where are each of these table located? What are the meaning of the table? What is the data inside it? What's the meaning of the column? There would be some lineage within your data lake, right? Let's say there's one table, and then some minor transformation happens over it, and then you have one more table. If you are not able to tell what's the lineage around this transformation, uh, I mean, you would not be able to do your analysis properly, because you won't be able to tell what's the source of the data. So data cataloging is a very important part, and it should be included when you propose a data lake architecture or when you build it within your organization. Same for data quality. Let's say you are so you have set it up a data lake. you have your data coming from, let's say, only five sources, and then you did some minor. So you have your data in one place. Now you did some transformation, and now your data is in, let's say, Tableau, and there's a sale number that is being shown there, and you are being asked that by your business stakeholder that I do not think that this number is right, and then you have to go back and check. Now, you, if at that point of time you are not able to tell that I'm confident that this data is correct, then there are credibility issues with the implementation that the IT team within your organization has done. So when you make a data lake architecture, data quality checks should be placed at that time only, so that if there is a data miss, if there is a data duplicacy, there are automated checks and there are dashboards for it, which are able to tell you that today, yesterday, or 5 days before, we had a issue in the data. We have to go and fix it. So these checks need to be placed automatically there, so that you know that there's a bug in the pipeline, in the data pipeline, and you have to go and fix it. If someone from the business comes and tell you that I do not think this number is right, and then you go back and check it, then this is a very long cycle, and this just won't fly. Next point is selection between ELT and ETL workload. So ETL and ELT are very common terms, but when you are preparing your data lake architecture, you have to choose one of them, or you can choose both of them as well. But I would just like to mention when you should use what. So ELT stands for extract, load, and transform, and ETL stands for extract, transform, and load. With ELT, what you do is, let's say you have your five systems, source systems, you will first extract and load the data into your raw storage, and then only you will do some transformation. So ELT is, you extract the data, load the data as it is, you do not do any type of transformation, any type of cleaning. You have your data in your data lake, and then you do the transformation. With ETL, what you do is, while you are fetching data from the source database, on the way only, before you dumped it into your data lake, you did some minor transformation over it, and then you stored it. So this is the basic difference. Now, which one should be used? So ideally, ETL workload is only suited when you are working with small amount of data. And why is that? Because you are fetching in data from your source system, and they are catering, of course they are catering to some production application, or even if they are a replica of the production, there is a limit to the amount of transformation that you can do on that server before you pull in the data. Or even if you are not doing the transformation on that server as well, but let's say a compute instance on the way, then also there is some limit to the amount of transformation that you can do before dumping the data into your data lake. So ETL is only suited for smaller workloads while you are fetching the data. But with ELT, that is not the case. You just load the data, dump it into your data lake, and then only you go and proceed with your transformation. One other important decision that should be considered while choosing between ELT and ETL is that if you are going with ETL, you would not have the rawest state of data in your data lake, because you are doing some transformation over the data and then you are loading it into your data lake. Uh, you have you have yourself with your code have done some changes to the code, and if there is some glitch in the pipeline and you have to fetch the data again, uh, it's a rework altogether. You have to go to the source system again to fetch that data. But if you are using ELT, you know that the raw data is already in your data lake. You do not have to go back to the source system again and again. So in our company in GroupI as well, we primarily use only ELT workloads. In very rare situations, we favor ETL workloads. So let me just give me a moment. So now we are done with what is a data lake, why do we need it, and what are some of the characteristics of a good data lake. Now let's see what does a typical data lake architecture even looks like. Like I have described, it's a place where you get all the data and then you do some transformation. But a typical data lake architecture would look like this. So on the left, if you can see, uh, just a second. On the left, if you see, you have your data sources, which are your OLTP databases. It can be your mobile application. It could be your web or log data as well. On the right of this diagram, you have your data consumers. Now, data consumer are your BI or analytics application, your data science guys, or even your end customers as well. So there's a journey from your source system to your end user who do your data analysis. And as you can see, there are three zones in this diagram: raw zone, conform zone, and model zone. But I would like to stress that it's not like we always have these three zones. Now, what are these zones? So, data is passing from source to destination, right? So, there's some bit of transformation, some bit of modeling, some bit of changing to the data so that the end user are able to perform their analytics easily over the data. I have to give you an example, let's say in the source you have your point of sale data, and then you have your customer data as well, and let's say you have your location master as well, and your end customer, one of your data analysts want a report which gives you, let's say, day wise sale of each city in India. Now, to give this report to them, you need to model the data in such a manner so that it is easily available to that end user, and that is a type of transformation that you do in the journey of data from left to right. So these three zones, it can be three, it can be four, and it can even be two. There's it all depends on what type of data lake architecture is best for your organization, is best for the scope of the project, and it should be a lot of thought should be given before finalizing the number of layers as well, because when you start and midway after 2 or 3 months, if you change your architecture, two or three of your pipelines will have only two layers, and then the rest of them will have four to five, and there's some rework that is needed to be done. So to avoid that, better is to spend around 3 to 4 days brainstorming on what should be the best architecture for the proposed use case. uh, so this slide shows you the possible implementation of data lake. If you can see on the left, the first two zones are highlighted, and in the right all the three zones are highlighted. So in the first implementation of your data lake, so as I said, data lake is a concept, and it's a concept, and the architecture can be different as per the need, and these are two architectures that can be, and I'm just showing you as an example which you can use as well. So in one of them, in your data lake, you have your raw and conformed zone. Raw is data as it is. Conformed is, let's say, you say you need to do some deduping over your data. There are some duplicate records, and you need to dedupe them. Maybe the name of the cities, you need to standardize them. You only need two-letter words for them. So this is the kind of standardization that you do from raw to conform. So you read in the data from your data lake only, and then you dump it again onto the data lake only. So let's take the example of S3. You read in data from S3, you clean it, and you push it back to S3 only. So both of these zones are in S3 only, and this is your data lake right now. Now the model zone in this case, let's say you have to build your PI tools over it. If you have to do some analysis over it, you can go and build your separate data warehouse engine, which is separate from your data lake. This can be a possible architecture. On the architecture to the right, all of the three components are within data lake. So how can this be achieved? It can be achieved after you can directly attach a Presto or a Hive on top of the conform data. And so Presto and Hive, they so these are SQL query engines, and they are able to query the data which is available directly on your data lake. So they use Hive Metastore, and they are able to query your data directly there only. And then the stored result are stored back into your data lake only. So these are two of the architecture. Uh, what you choose is as per your choice. What is best for your use case? I would like to say that, because if you are going with a SQL query engine, the performance would be slower than the first architecture if you are going with a data warehouse. But then if you have to do some ad hoc analysis where you do not know what table you need for modeling your data, you would of course need to do some SQL queries directly on top of your data lake as well. So maybe you can do a mix and match of both of these architecture as well. So with the now on this slide, I'll talk about what are the pain points with our current scenarios. When I say current scenario, I'm talking about the blob storage. If we are implementing our data lake with with an architecture which is based upon blob storage, let's take S3, Google Cloud, or GCP, any one of them. So if you take a blob storage, for instance, and you are going with ELT methodology, uh, you have your data in your data lake. Let's say data is already there. Now, if you have to do some transformation over it, you have to write your in big data world. You will write your PySpark code over it, as you can see here. So that's a different component that you have to use. Maybe you will use a separate software like Databricks or AWS Glue or any EMR. You will use what is best for the situation. But then you are adding more services on top of your data lake. uh, Maybe when once your transformation is done, you will take your data backup and push it in a different location in S3, and your transform data you will push it to your data marts, your data warehouse. And then if you are doing your directly your Presto or Hive queries, you would again make one more copy of the data of your resulting data set. Now in this architecture, even though it's not too complex, but with the amount of data, there are multiple hops via which the data is traversing, which makes it extremely difficult to implement proper data governance and data quality. And it adds more to the cost as well, if I have to comment on that, because you pay for cloud storage as well. Even though storage is cheap, you do get companies get data volumes of amount 300 to 4 GB daily. Now, if there are multiple copies of data, they would end up paying more and more over the course of time, and you incur cost on network bandwidth as well. So this is one of the pain point with the current scenario. Now, on this slide, we'll talk about if you were to implement in Snowflake, how would it make your life a bit easier? So, first of all, so Snowflake is completely SQL based. So, uh, if this is the first time you are attending our session, I would request you to go and watch my first session as well, where I talked about the Snowflake architecture as well. So, just to give a brief, in Snowflake, everything is SQL. You do not have blob storage. I've talked about it previously as well. But since everything is stable, everything is relational like, the query performance is of course better if you run a query on a file type storage. Then there's integrated data pipelines with extensibility. So as per the data Snowflake architecture, it is very easily scalable with decoupled storage and compute. And the data pipelines which you write in Snowflake are quite extensible, because what you end up using is simple SQL, which a lot of us are already familiar with. You do not need an expert who is in PySpark expert or an Hadoop expert if you're going with Hadoop. So simple SQL, and you should be able to use robust pipelines. Then g- governance and govern and secure collaboration. So how this is easily achievable by Snowflake is very simple reason, because in Snowflake you will not have multiple hops of your data. All of your data, your raw data, your conform data, and even your data warehouse, all will be within Snowflake. So your admin team, your they do not have to go and monitor multiple places. They just need to write proper RBAC policies within Snowflake for your users. They need to create appropriate roles for them, and they should be able to achieve appropriate governed and secured collaboration over the data. And Snowflake provides encryption of data at storage and at its retrieval as well. Now, if you have to implement data lake in Snowflake, how can you go about doing it? So there are two ways. One is you complement your data lake with Snowflake, and one is you build your data lake with Snowflake. The difference is, because Snowflake is a newer technology and the blob storage were already there in place. So many companies have already invested a huge amount of money into their current architecture, which is already available on, let's say, AWS or Azure for that matter. And uh, since their data lake is already there, it doesn't make too much sense to scrap out all that architecture altogether and completely move to Snowflake. So what can be done here is what is generally done in these cases. The raw layer is maintained at the blob storage only, and you only pull the data and you only keep the conformed and the data mart or data warehouse kind of data within Snowflake, and the raw data is available with your cloud provider only. And the main reason for that is maybe your data science team, maybe your other data application, they are reading in data from your S3 and from your blob storage, and you would not want to disturb that pipeline. The other architecture is, let's say the company has not moved to the blob storage. So you can essentially fetch in the data directly from their data sources into Snowflake. So this is also one of the possible architecture, and where there would be no disturbance of blob storage, the cloud storage in between. So these are two of the popular architecture in which you can utilize Snowflake within your organization. Just a second. Yeah. So the next slide is, so we have talked about what are the two cases, what are the two ways in which data lake can be implemented in Snowflake. The next point is, how do you actually go and load the data into Snowflake? So there are, of course, two options from the last slide. One is load your data directly to into Snowflake. Now, to do that, Snowflake has a huge connect of its technology partner connect. One popular example is Fivetran, which is a ETL tool which connects directly to your database, and it dumps your data directly into Snowflake, and it is a completely drag and drop tool, and it is being heavily utilized by a lot of companies out there. Maybe around 250 to 300 customers they have jointly together. The uh, the partner that Snowflake have, they give you the capability of drag and drop, of course, and then simpler transformation of data, SCD1, SCD2, merge into columns. They are readily available with drag and drop only. So this is one of the way on how you can load the data into Snowflake. Another one is the first approach. If you as an organization have already invested highly on your blob storage, then you can pull in the data from your blob storage into Snowflake as well. You can use Snowpipe, which is nothing but, as soon as a new file gets dumped into your S3 or Azure bucket, it will automatically be fetched into Snowflake as well. You can do this automatically as well, or you can do it on schedule as well, like once a day with the copy command in Snowflake. One more popular way is you can create external table with materialized view in Snowflake as well. So what this essentially mean by external table is data will remain in your cloud storage only, but Snowflake will use Hive Metastore of the cloud storage and will query the data directly on the cloud storage only. But this is generally slower compared to if data is already on Snowflake. But to make it fast, you can make a materialized view on top of your external table, and then your query performance will skyrocket. Then you have your Kafka data as well. So Snowflake is very good in handling semi-structured data as well. So Snowflake has native connector for Kafka as well, and you can use that to load in data directly from your Kafka broker. Now the next slide is data movement within Snowflake. So we saw how we load the data from into Snowflake. The next point is uh, once the data is in Snowflake, how will data move within Snowflake? What are the ways in which you can move the data in Snowflake? Because the data lake architecture does not end at only raw layer. You have to prepare your n number of layers that you have in your architecture. So based on the frequency of your refresh rate, when I say frequency of refresh rate, it's, let's say you have a n dashboard which needs to get refreshed at every hour or every 3 hours, then you would need to move your data accordingly from your raw to confirm to gold layer at every 1 or 2 hours. If it's a daily schedule, you would run your jobs at daily manner. You should be mindful if uh, as real time as you try to go, the more the cost you are going to incur on your data lake architecture. So one should be mindful of their business users needs before committing anything. How you can do that directly in Snowflake is you have task and streams within Snowflake. So tasks are nothing but stored procedures which you can run on schedule, which again you write in Snowflake only. Sorry, SQL only. I'm sorry. And then you have streams as well, where streams are basically used to process your clickstream data. Uh, and for transformation, you can use Snowpark as well. So Snowpark is a Python library introduced by Snowflake only, where you write your code in Python, and it's not only available in Python, it's available in Java, and I think, if I'm not wrong, in Scala as well. You write your code in your native language, in the choice of your IDE which you like, but the query will come and run onto Snowflake only. So you do your development in the language of your choice, but ultimately Snowflake will convert whatever code you have written into SQL, and then it will do your transformation in Snowflake only. There is no movement of data as well, so data security is still maintained. Then you can use dbt is a very popular transformation tool. We have done many implementation by with using dbt in BluePy, and development using dbt and Snowflake has proved to be very easier, and it has received very good feedback from our developers. And once these are all in place, you have your jobs, then you need to maintain some kind of orchestration of your jobs as well. And you can use Airflow for that, for orchestrating your data pipeline, all of your data pipeline, even from raw to last layer. And then, of course, like I talked about, you need to have data cataloging and governance as well in place. So this is what your typical This is a very small example of what a data lake architecture would look like in Snowflake. If you see on the right hand side, dev is the name of the database that that I created for the purpose of this demo. DWH, processed, and raw data are the name of schema. So these are you can consider as the three zones that I've created. Raw data is the data that is coming directly onto Snowflake, unprocessed. Raw to processed, the number of tables are also decreasing. I'm doing some transformation, and then processed to data warehouse schema. I'm doing some data modeling. I'm making my data marts, and all the tables are in relational format only. Of course, the storage is not row level; it's columnar. But since it is like this, it is very easier to do your data analytics over. So this is what a traditional data lake architecture, a data lake, modern data lake architecture would look like in Snowflake. So now we are on to our last slide. So here I would just want to compare, Snowflake with Blob Storage. Most of the points I've already uh, covered. I'll just read this out. Snowflake gives an integrated data lake and data warehouse platform. So Snowflake, you have your data lake and data warehouse all in one place. With your blob storage, you would have your data lake, your object store is different, your SQL analysis in a different place, your Redshift in a different place, all will be in different place. Then data lake based on relational schema as opposed to files in blob storage. Yes, we have already talked about it. Easier to update. So Snowflake, you have your rows and columns, right? So if you have to update a row, you can go and update that row only. But if you're talking about a blob storage, you cannot go and update one row of a particular file. Let's say the size of file is 128 MB and there are 1,000 records. You have to replace the whole file and you cannot go and edit or delete one row with that. Easier to maintain data security and governance with all the data in one place. This is done. Unstructured data support with blob storage. So with blob storage, you can save your image data, your text data as well. This is not available in Snowflake. So if your data science team need to train some model, some computer vision workloads, then you would need your blob storage as well. It's not like you can move it completely out of the picture. Snowflake is more user friendly, and Snowflake can cater to your data engineering and machine workloads as well on the same platform. So you can essentially read in data from Snowflake only, and you can save your features back to Snowflake only. You would not need to, use one different service to essentially run your machine learning or data science workloads. You can again, I mean, you will train your models in Snowpark, they will run in Snowflake, and that's it. You are done. So that's about the end of my presentation. If you have to do some trials, you can do a hands-on on Snowflake by registering on the Snowflake website. Feel free to go there and try your hands on it. Thank you very much. If you have any questions, please feel free to reach out to me. Now we'll go to the Q&A session. Let me see the questions. Can we have both data lake and data warehouse in a single platform? Yes, we can. Can Snowflake act as a query engine for your already existing data lake? Yes, of course. So you can use external tables, and with the use of that, you can use Snowflake as an external query engine, uh, which will run your queries over the data that is already stored in your blob storage. If there are no more questions, we can move to the feedback part. So you should be able to see your feedback button to your right. Uh, Please give us your feedback. We It is very helpful for us to improve our sessions. Please feel free to reach out to us. Thank you very much.
Hello, everyone, and thanks a lot, Divya, for this very informative session. For any more questions and your valuable feedback, please feel free to mail us at the email address that we shared. Also, please follow our channel on YouTube and LinkedIn for regular updates on these sessions. Thanks a lot for joining, you guys. Have a good day.